work on this one. It's a supplement for last year, 2023. Without any waste of time, let's get into it. Okay. So when read the question here, it says an electric motor pulls a 20 kg crate from rest. Okay, which means from here it's from rest up the inclined plane by means of the light inextensible rope, which means I mean to say the tension is the same anywhere in this rope. Okay, now the inclined plane makes an angle of 18 degrees. That's what they're telling us with horizontal. B, C, and D are point on the inclined plane, and the distance between point A and C is telling us from A to C. This becomes what the distance as shown in the diagram below. You have this electric motor. So to make it short, these things of electric motors, just treat them like they're actually like a force supply thing. Okay, just take this one as in like in a force supply. That's all. Like, okay, so with that, we can have in our mind that we have fully understood the statement. Okay, now they also say something here. They say it here, the motor, okay? Now the motor exact constant force. That's what they're telling us here about the motor, okay? This is 96.8 Newton. I took this one. To me, I just took this one as a force supply to keep it simple, to make things easy for me. To the inclined plane on the rope, a constant friction. So they're telling us that here, the friction over here, okay, as it moves, friction constant friction force 8.5 acts on the crate as it moves up the incline. They're telling us the friction over here is this is the value. Okay, so the first one, define a non-conservative force. Okay, I just wrote it over here to make things easy and also to have like save time. Okay, so a non-conservative force. Now, so the work done on an object which is moving between the 2 points depends on the pad taken. It actually depends on the pad taken, like a friction. Friction would depend on the slope of this one. So in this case, the friction would act in this direction. When it's going, the block is going down, it's going to act in the opposite direction. So that's why it depends. Like a force applied also depends, and so forth. Okay, so that is the idea. So they depend on the pad taken. That is a non-conservative force, but the conservative force like Fg, they don't depend on the pad taken. Right, let's go to the next question. We're gonna go to one question 5.2. Let's go to 5.2. Okay, now use energy principle to calculate the speed of the crate when reaches point C. So they want us to get our V final over here. Let me just write that. They want us to get like V final over here. Okay, they're looking for the final velocity at this point. So what do we have? We have the displacement. Okay, so we have an end over here. So there are two ways, and actually there are more ways to do it. Okay, but I just want to make it easy for me because I want to work with this one. Okay, I'm going to use work energy theorem. Okay, so work net equals to change in EK. Okay, if I expand this, will be 1 over 2 m, and therefore V final squared minus V initial squared. Okay, and I can further expand this. I know that my work net is the same as my F net, changing X cos theta. Okay, all right, so now let's get to our F net. I'll start with my F net. I will just expand. I'm using the work energy theorem just to make things easy for me. There's also another way I'm going to show it. So we're going to work our F net. Working our F net over here, as this thing moves up the incline, we have these. The motor is actually exert force by pulling this thing up. So we're gonna need the motor force, which is 96.8. So we're gonna open bracket over here, 96.8 should be positive because pulling this thing, supporting this object. Okay, and therefore plus, I'm going to open bracket. For the other one, we have a friction opposing the motion, which is my negative 13.5. Okay, 13.5 they told us over here. And the other thing I'm going to say plus, open bracket, my negative what, my FG parallel, it also opposes the motion because it's acting down the incline, which means it's going to be my negative. I'm going to say, let me just write like should I have to write FG parallel? I'm just gonna write like this one. I'm gonna indicate above here. So for this one, it's going to be 20 times 9.8 sine of n 18. We guys know that your FG parallel is the same as FG sine theta. Just take a note to all this. Okay, I hope you know that. Okay, so that's our F net, and therefore we're gonna put the square brackets like this just to show that this is for my F net. And therefore the displacement here they told us is 15.6, which means we're gonna multiply by 15.6, and therefore cos of 0. I'm gonna write over here. Let me just write over here, and therefore cos. Sorry about that. Okay, and therefore what's happening? Okay, then cos of 0, and then cos of n 0. I'm still on this part, and therefore a equals 2. And then after that, this one is going to be 1 over 2. The mass for this thing is 20. I'm going to put like my 20 over here, open bracket. I'm looking for my V final. It's going to be VF squared minus my initial. It's from rest. So from here, it's 0. They told us on a statement over here from rest at point A. So here, it's 0. Okay. And then after that, we're just going to work on the calculator. So I'm going to try to punch all the way from for this one. Sorry, we'll start here. You multiply this one for your F net. You're gonna get that your F net is going to be say calculate, it's going to be 22.733, right? 733, and therefore after that your displacement is this one, 15.6, and therefore cos of 0 is going to be 1. I'm just going to leave it like that. Put the equal sign. Equals to, when you punch this will be 0, which means only going to say 1 over 2 times 20 is going to give you 10, which means going to be 10, and only here we're going to be left with VF squared. Okay, and therefore we're just going to divide by 10. Okay, we're just gonna just divide by 10, and all this divisible by 10, and therefore we're gonna be left with what's the value over there? I'm gonna start with the one at the top. So when you multiply these two, you're going to get is 354.629. Then all over your 10, and therefore over here you're gonna have your VF squared. Now this will cancel this, and then your VF squared, just swap things, and therefore when you divide this, just put the squared. Yeah, just put the squared here, and therefore you also put the squared over here. It's going to be 354.629 all over your 10. Then you're gonna get your VF. It's gonna give you what? Punch that on a calculator. It's gonna give you 5.96 equals to 5.96 meters per second. Now we got the velocity at point C, which means it's 5.96. All right, that was 5.3. Okay, there are many ways to do it. You can also calculate this height. Sorry. You can also calculate this height over here, and therefore work with work done by non-conservative forces, but it's up to you. You can also do it like that. Okay. Now let's go to 5.3. So when we get to 5.3, okay, let me just scroll down. Okay, so when we get to 5.3, you 5.3. Okay, they say here calculate the minimum average power dissipated by the electric motor to pull the crate from A to C. From point A to C, they want the power. So there's two formulas for power. The first one says P, power, it's work done, is the rate at which work is done, and power is equals to force times V average. Okay, and this part is the easiest formula to pick. Okay, why? Because I have my initial and my final velocity, so I can get the average. Average velocity. So your P is equals to the force, because I do the one exerted by the motor, and V average. Okay, what is the force by the motor? It's 96.8 Okay, and therefore your average velocity, the average velocity is going to be, you're just going to add the two, initial and final, then divide by 2. It's going to be 0 plus your 5.96, then all over 2. Okay, so and after that, you're going to punch this on your calculator. You're going to get 288 comma 46. Going to get 288 comma 46. What, that's how you're going to get this one. Okay, that was 5.3. Okay, now let's go to the next question. Okay, so they say there, when the crate reaches C, okay, when the crate reaches C, the rope breaks, which means this rope actually like breaks. Okay, now the crate continue moving up the incline, comes to stop at D. It comes to stop at, which means here, just like this velocity, and therefore slow down and stop here. And then slide down the plane past point B, and therefore it's slowed like down, then past this point B. This is what they're telling us. Okay, draw label free body diagram for the motion for the crate as it slide down the plane past point C. So they want the free body diagram, 3 marks. Okay, 3 marks, 3 arrows. That's simple. Okay, so what we're gonna have? We're gonna have the normal force in that part. We're gonna have our, since it's moving, we're gonna have our Fk, and therefore we're gonna have our Fg. Okay, you can just write over here, or you can just write where it's up to you. That is a free body diagram, and therefore 5.5. They said draw the velocity time graph for the entire motion of the crate starting from point A until past point B. Again, on its motion down the inclined plane. So they want us to draw the velocity versus time graph. Okay, how are you going to draw that? We're gonna use that mindset of projectile. Okay, I'm gonna draw something like this one. Okay, it's not that straight, but I'll try to use it. Okay, and therefore over here, this is my time in second. This is my my velocity in meters per second. Okay, there you go. Okay, so as it moved from here to here, it was actually accelerating. Okay, the constant acceleration, it goes from 0 up until it get to the value of 5.96. 5.96, and therefore from this point it slows down. I mean, let me just, yes, from this point it then slows down. Check, it happened quick. Why it happened quick is because there's Fg parallel and also the friction. So which means at this point it take a lot of time. It happens like real quick. You can just do it like this one. Okay, and therefore this is the time about at point D. What happened after that? It then goes down. Okay, now this thing, we have the Fg parallel putting this thing down, and therefore we have a friction in opposite, which means we expect this to move slightly a bit. Sorry about that. To take a bit of a time. Okay, to take a bit of a time, so we can just draw something like this one. Oh, it's not writing, sorry. Okay, there you go. Take a bit of a time and just do like this, and therefore you're done like this. So that's all for the velocity versus time graph. That was 5.5. Okay, so yeah, till the next tutorial exercise, signing out.